Hey everyone, welcome back to another session. In this session we are going to discuss question and answers from the chapter Periodic Classification of Elements. It is chapter number 5 in NCERT textbook. This chapter is very important, so I have tried to include previous year's question plus some very important question from this year's sample paper. So let's begin today's session. Question number 1. The elements of the second period of the periodic table are given below. Lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. Now here in the question they are telling that they all are in the second period. So from here we know that it is the second period. So accordingly we will be knowing some characteristic of them. Like if they are in the second period, they have same number of shell. So same number of shell, that is it is in the second period. So the number, the second period tells that it has got 2 shells. Okay, so they are having only 2 shells. Like this one, this is lithium, so it will have 2 shells, one shell and second shell. K and L shell are there. Okay, similarly beryllium will also have 2 shell, boron will also have 2 shell, carbon will also have 2 shell. Okay, so they all will be having 2 shells in them. Now question number A, the part A, give reason to explain why atomic radii decreases from lithium to fluorine. Okay, see lithium is the first element here in the second period and fluorine is the last element, although it will also have 2 shells. That is why they are asking that why the atomic radius will decrease as we go from lithium to beryllium. That is lithium, beryllium, boron, carbon and then nitrogen, then oxygen and then fluorine. Why the atomic radii keeps on getting decrease? So the reason is this, that the atomic number of the lithium is 3, beryllium is 4, boron is 5, carbon is 6, nitrogen is 7, oxygen is 8, fluorine is 9, right? So its electronic configuration will be 2, 1. So 2 in first shell and 1 in the next shell. If you see beryllium, 2 we can put maximum in the first shell, so 2 will be there and 2 in the outermost shell, right? If you see boron, 2 will go in the first shell because the first shell can take maximum of 2 and remaining 3 will be there in the next shell, that is the second shell. Carbon 6, so 2 in the first shell and 4 in the second shell here. Okay, nitrogen if you see 1, 2, so in the first one obviously 2 and they will, the rest of them will be distributed, that is 5 will be in the second shell. Oxygen first shell it will have 2 and the next shell will have 6, 2, 6, 2, 2, 4, 5 and 6. If you see fluorine, first and second shell, first will have 2 and 7 will be there in the second shell, although they will be distributed evenly. I am just drawing like this, but when we will draw the full circle they will be distributed evenly, 2, 2, 4, 5, 6 and 7, right? Now you can see that in the second shell at every step 1 electron is being added and similarly 1 proton is there obviously getting added inside the nucleus. So the pull between the last shell and the center of the atom will be increased. Now here it is 2, so obviously the pull will keep on getting increased, that is the effective nuclear charge will increase, and because of that we will see that the atomic size will keep on getting shrinked from lithium to fluorine. Okay, so in the outermost shell at every step 1 electron is being added and at the same point of time 1 proton is also getting added inside the nucleus. So the effective nuclear charge or the pull by which the last shell is being held, it will get increased. So it will be getting pulled with strong force and that is why the size will decrease. So you will write here that the effective nuclear charge will increase. Effective nuclear charge will increase as we go from lithium to fluorine, and therefore the atomic radii decreases from lithium to fluorine. Identify the most metallic element and the most non-metallic element. Always in the beginning of the period we are having the metals, and at the end we are having the non-metals. So most non-metallic will be lithium, because if you see its atomic number is 3, its electronic configuration will be 2, 1. So obviously to fulfill its valency, that is like it needs 7 more electrons, but there is no one who will give 7 electrons, right, to complete its octet. So what it will do, it will lose this 1 electron. Okay, so losing 1 is quite easy also, and this is why, and that is why lithium is the most metallic element here. The most non-metallic element will be the fluorine, because fluorine 9, its electronic configuration will be 2, 7. It is in need of only 1 electron to complete its octet. So that one it can take from any other metal which is willingly ready to give, like lithium. So fluorine will be the most non-metallic element here. Now let us go to the next question, that is the question number 2 here. Question number 2 is having the a portion of the table, the elements of the third period. This is the third period, right? So it will have 3 shells, remember. All of them will have 3 shells. Which atom is bigger, sodium or magnesium? So this is the third period. They are having 3 shells, 1, 2, 3. It will also have 1, 2, 3. But the atomic number of the sodium is 11. So it will be 2, 8, 1 here, right? Magnesium is 12, so it will be 2, 8, 2. So obviously here in the last shell there is only 1 electron, and here there are 2 electrons. So again the effective nuclear charge will be more here. With more force they will be pulled towards the center of the nucleus in the magnesium atom as compared to the sodium. So the size will keep on getting decrease as we go from sodium to chlorine, right? So obviously which atom will have bigger size? Sodium will have bigger size, because sodium size will be bigger. After that magnesium, then aluminium, then silicon, then phosphorus, then sulfur, and then chlorine. Chlorine will have the smallest size here. Identify the most metallic and non-metallic. Again it is the same type of question which I have discussed in the question number 1. So in the beginning they are the most metallic element, and out of them sodium is the most metallic element, and at the end here they are the most non-metallic element. Okay, so you can write here Cl, which is a halogen here, right? So let's go to the question number 3. Now question number 3, the table shown is having a portion of the periodic table in it. Okay, atomic size of magnesium is less than that of Na, right? So this one we have already discussed. This is the first period, this is the second period, this is the third period. Okay, now sodium and magnesium, okay, as we move in a period, okay, from left to the right, the atomic size keeps on getting decrease. Why? Because the effective nuclear charge is more as we go from left to right in a periodic table. So the sodium size will be more as compared to the magnesium. So atomic size of Mg is small. Magnesium atomic size will be small as compared to sodium, because of effective nuclear charge which is getting increased. Effective or the total nuclear charge, you can also write that word. Effective nuclear charge increases. Okay, fluorine is more reactive than chlorine. Fluorine is more reactive than chlorine. Okay, so now this is the group basically. So fluorine and chlorine, they fall under the same group. When they are in the same group means they are having the same valency. Okay, so it is group number 17. Okay, so it will have, but it is in the second period fluorine, so it will have 2 shell. Chlorine is in the third period, so it will have 3 shells, 1 2 3. Okay, but the group is here 17, that is it will have 7 valence electron, 1 2 3 4 5 6 and 7. Okay, here also 7 valence electron will be there, 4 5 6 7. Now see, here it has got 2 shells, so the second shell is quite close to the nucleus, right, as compared to the third shell. Okay, this is the first thing, that the distance is more in case of the Cl from the center as compared to in the fluorine. Now they both are in need of 1 electron, right, to complete the octet. So if you will give 1 electron here and if you will give 1 electron here, then what will happen? In fluorine it will be accepted fast. Acceptance will be fast. Why? Because it is lying, like it is entering into the second shell, which is more close to the nucleus. So the pull is there. Okay, the pull is more here. If you see in the case of Cl, it will be accepted, no doubt, but the quickness will be less as compared to the fluorine. That is why fluorine is more reactive than chlorine. Okay, because the incoming electron is being added to the second shell and second shell is more close to the nucleus, so it will be accepted fast as compared to the Cl, right. Then let us go to the question number 4. In the following table, 6 elements A, B, C, D, E and F are here. Here letters are not the usual symbols of the element, that is the element symbol is not used. Okay, so you will have to give answer in A, B, C, D, E and F until and unless they will not ask you to identify that particular A, B, C, D, E, F. Okay, so table with atomic number 3 to 18 are mentioned. So this is the atomic number 3 and the name is A here. Okay, meaning to say. So now let us go to the question part here. Which of these is a noble gas and which of these is a halogen, right? So you will have to identify a noble gas and a halogen here. Noble gas means inert gases they are talking, okay, in which valency is 0, remember. So group 18 elements they are asking here, and halogen, you know, that is valency should be 1, valency should be 1, valence electron should be 7 and they are in group 17, right. Now noble gas, so obviously here if you will see atomic number is 10, so it is 2,8, right. So it means the last shell is having its octet complete. Octet is complete here. So our answer will be G. Answer will be G. Atomic number 10 belongs to G, right. So here the answer will be noble gas, answer will be G. Now halogen. Halogen should be having 7 valence electron to it. So if you see 17, it will give you 7 valence electron. 2, 8, 7. So 7 will be the valence electron. So valency will be 1 because it will be in need of 1 more to complete its octet. Okay, and obviously it will be coming in the group 17 itself. So fluorine, or sorry, F, not the fluorine, we will be saying F will be the halogen here. Okay, if B combines with F, that is if B combines with F, what would be the formula of the compound form? Okay, now as you know that the formulas are formed using the valencies, right. Compounds are always formed using valency. So you will have to identify their valency first, right. B and F valency you will have to identify. Now see, where is B? This is B here. Okay, so the B atomic number is 11, right? 11, that is 2 comma 8 comma 1, so it will lose this one electron, so its valency will be 1. Now F is here 17, so it is 2 comma 8 comma 7, so its valency will also be 1 because it will be accepting one more to complete its octet. It will be losing 1 to complete its like to take 2 comma 8 electronic configuration, right? So they both are having valency 1 to them. So B and F, B valency is 1, F valency is 1, so this one will go there, this one will go to its neighbor, so it will be BF. Similar valencies, or if the valency is 1, it is never shown, so the formula will be here BF only. Write electronic configuration of C and E. Now C is atomic number 12, so you will be writing 2 comma 8 comma 2 here. E is where this one, this is E, it is 8. Okay, so it will be 2 comma 6, right? Very simple one. Now let us go to question number 5. This is question number 5. Now see, atoms of 8 element A, B, C, D, E, F, G and H have the same number of electronic shells. First hint is same number of electronic shells. Same number of electronic shells are always there in same period. In same period, right? But different number of electrons in their outermost shell, right? If they are in the same period, they will have the same number of shell, but in the outermost shell, one electron will be getting increased at every step. It was found that element A and G combines to form ionic compound. Okay, A and G combines to form ionic compound. That is, they are itself in the ionic state, or they can easily come in ionic state, and that is why they are forming the ionic compound. And another information you will be getting here, that one is a metal, another one is a non-metal, right? Which can also be extracted from seawater. Okay, a very popular compound which is taking which is usually taken out from seawater is common salt. If you will read the question, you will find that there are many hints there. Okay, common salt is what? NaCl. Okay, oxides of A and B are basic in nature. So again there is one more hint. A and B oxides are basic in nature. They are basic in nature. Okay, meaning to say what? They are metal. Metal oxides are basic in nature. So obviously here we are saying that they are forming ionic compound. So I have told that one is a metal and another one is a non-metal. So from this point it is confirmed that A is a metal. A is a metal. So obviously G will be a non-metal. Right? While those E and F are acidic, right? So they are acidic, meaning to say E and F are non-metals. Acidic oxides are formed by non-metals. Acidic oxide, they are formed by non-metals. Okay, the oxide of element D is neutral. Okay, this D is neutral. That is, it is a metalloid, you can say. D is a metalloid then. Okay, answer the following question on the basis of the information. So we have collected the information here. So we will try to give answer from these points which we have understood. To which group or period of the periodic table do the listed elements belong? Now see, for that there is a hint that the common salt which is obtained from the sea, okay, it is, which can also be extracted from seawater. Okay, so they are talking about the period 3. They belong to the period 3 here. It is period 3. Okay, which will start with the sodium, magnesium, aluminium, silicon, phosphorus, then sulfur, then chlorine, right? It is 11, 12, 13, 14, 15, 16, 17, right? And then 18 is argon. Okay, so this is the period 3 because NaCl will be formed from here only, na, Na and Cl, right? So this is period 3, 2, 8, 1. So 3 shells will be there. So it is period 3 here, right? And the groups will keep on getting differ. Okay, groups will be different here. We just cannot write all the groups. Like sodium, you can write it will be in the group 1, then you can write in the group 2, then 13, then 14, then 15, then 16, then 17, then 18. If you wish to write, you can write like that also, but period will be 3 here. Which one of the 8 element is likely to be a noble gas? Okay, the noble gas or the inert gas. So obviously it will be the argon, which is in the last. So here H is last here, so you will be writing H here. Which one of the 8 elements would have the largest atomic radius? It will be A, that is the sodium. The first one is always having the largest atomic radius, followed by the last one, argon, because as we move in the same period, atomic size will keep on getting decrease because of the increased effective nuclear charge, right? So it will be getting decrease. Which 2 element among these are likely to be non-metals? So you can write Fg. Fg will be the non-metals here. Okay, like here sulfur and chlorine, they always form the acidic oxides. Which one of these 8 elements is likely to be a semi-metal or a metalloid? Which is here D, because it is forming the neutral oxide, right? So in this way, slowly you will have to understand the question, keep on collecting the information which is mentioned in the question, and then try to solve it. Now let us go to question number 6. Yes. Now let me show you the question. Again, atoms of 8 elements A, B, C, D, E, F and G, H have the same number of electronic shells. So again, they are in the same period. If the shells are same, so it will be in the same period, right? But different number of electrons in their outermost shell. It was found that element A and G combines to form ionic compounds. It is forming the ionic compound. It is quite similar to the previous question. Okay, ionic compound, so that is they both are forming ions, that is why they are forming the ionic compound. So one will be a metal, another one will be a non-metal, right? This compound is added in small amount to almost all vegetable dishes during cooking. Okay, so the hint is here, obviously it will be the salt. Okay, it will be salt. It is added in the cooking of vegetables. So it is common salt, that is NaCl. Oxides of A and B are basic in nature. So again, they are, if they are basic, they are metal. Metal oxides are basic in nature, right? And E and F are acidic in nature. So obviously they are non-metal. Okay, then the oxide D is neutral, that is D will be a metalloid. So the question is very similar to the previous one, except that there they have mentioned that the compound is obtained from the seawater, and here they have mentioned that it is added to the in a very small amount to the vegetable dishes during cooking. Okay, to which period or the periodic table do the listed elements belong? It will be in the 3rd period. Okay, as we have discussed in our last question. What would be the nature of the compound formed by the combination of B and F? So for that you will have to see the valency. B will be Mg here. Okay, B is Mg. If you check the third period, Mg will be coming, that is A is sodium, B is Mg. Okay, C here is aluminium, D is silicon, E here is phosphorus, F will be sulfur, G will be chlorine, and H will be argon, right? So if you can see that magnesium valency is 2, 2, so B valency is 2. Now F is sulfur here, so sulfur is having atomic number 16, so it will be 2, 8, 6. So it will be in need of 2 more electron to complete its octet, so its valency will also be 2. So this 2 will go here and this 2 will go here, so it will be BF, because when valencies are same, they are never shown, remember. So it will be BF here simply. Which two of these elements could definitely be metal? Okay, metals always lie at the beginning of the period. Okay, so it will be sodium, magnesium, you can write simply sodium comma magnesium. Which one of the 8 elements is most likely to be found in the gaseous state at the room temperature? Non-metals are mostly gaseous, you can write simply chlorine. If the number of electron in the outermost shells of C and G be 3 and 7 respectively, write the formula of the compound. I think this is the question there. By the combination of 3 and G, C and G here, right? So if the number of electron in the outermost shell of elements is 3 and 7, so if C is having 3 electron in its outermost shell, so it will be giving it, that is the valency of C will be 3. And if G is having here 7 electron in its outermost shell, then it is in need of 1 more to complete its octet, so it will be accepting 1. So this will become its needs, that is its valency. So this 1 will be, that is the valency of G. Now this 1 will go to C and this 3 will go to G, and therefore it will become Cg3. The compound will become Cg3, right? Now let us go to the next question. Okay, question number 7. In the following table, there are 8 elements A, B, C, D, E, F, G, H. Here letters are not the usual symbol of the elements of the modern periodic table, with the atomic numbers of the element in parenthesis, that is in the bracket they have mentioned, right? Now this is the portion which they have given. They have mentioned group 1 and group 2, and these are the symbols of the elements which they have used, and inside the bracket they have written their atomic numbers. Okay, now question number 1, what is the electronic configuration of F? F is here, atomic number is 12, so it will be 2, 8, 2. So this is the electronic configuration here, 2, 8, 2. Okay, what will be the number of valence electrons? Valence electron they are asking, not valency, keep in mind. Okay, so valence electron will be 2. This is the electronic configuration. So in the last shell it is having 2 electrons, so 2 electrons will be there in the last shell. What is the number of shells in the atom of F? So this is first shell, this is second shell, this is the third shell, so the number of shells will be 3. Write the size of the atoms E, F, G and H in decreasing order. Okay, so if they are in the same period, then you know that always atomic size keeps on getting decreased as we move from left to right. E, F, G, H, this is here E, F, G, H, right? Now E belongs to the period 2, that is it will have 2 shells. G is there, F is there in the period 3, so it will have 3 shells. G is having 4 periods, so 4 shells, and H is 5, so it will have 5 shells, right? So obviously the size will be more in case of H, Okay, H size will be the largest because in the group the atomic size keeps on getting increased as we go from top to bottom, because the number of shell is getting increased, right? So it is in the same group, not in the period. They all belong to group 2. Here it is mentioned, right? So obviously the biggest size will be of H, followed by G, then F, and then E. Okay, so this is biggest in size. State whether F is a metal or a non-metal. So electronic configuration of F is here 2,8,2. So in the last shell it is having only 2 electron. It is in need of 6 more to complete its octet. Okay, but if any other atom is having 6 electron in its outermost shell, it will not give it to any another atom. Okay, they will try to gain itself. So what it will do, it will lose 2 electrons. So since it is losing, so it is a metal. Non-metals always gain and metals always lose. So it is a metal. Okay, out of the 3 elements B, E and F, which one has the biggest atomic size? So where is B? Here it is B, then here it is E, and here it is F. Okay, now out of E and F, F will have bigger size here, right? Okay, now question is between B and F. Now see, B and F belong to the same period with 3 shells, 1 2 3 1 2 3, right? Now when they are in the same period, the atomic size keeps on getting decrease because of the increased nuclear pull, or the total effective nuclear charge is getting increased. That is why B will have greater size as compared to the F. So answer will be B here. Okay, now next question. Yes, did Mendeleev have gaps in his periodic table? Yes, Mendeleev left some gaps in his periodic table to adjust the undiscovered elements basically. Okay, any 3 limitations of the Mendeleev classification: position of the hydrogen, you can say, because it was showing resemblance with both alkali metals and as well as with halogens. Then increasing order of atomic mass cannot be maintained, remember. Okay, because in its periodic table, if you go through well, you will see that just to satisfy the chemical properties, that is the oxides of the oxides and the hydrides, he has placed some higher atomic masses after to some lower atomic masses, right? So the increasing order of atomic mass cannot be maintained. And yes, position of isotopes, because all that this isotopes, his periodic table is based upon the increasing order of atomic masses, and isotopes show variation in their atomic masses although they belong to the same element. So there was no place to adjust them. Does electronic configuration of atom change in a period with increase in atomic number? So see, the number of shell remains same. Number of shells remain same, right? But valence electron keeps on getting increased by 1 when we move from left to right in the period. Okay, like this. Now let us go to the next question. Which 2 criteria did Mendeleev use to classify the elements in his periodic table? First was the increasing order of atomic masses, right? And then second was the chemical property, especially the formula of oxides, and the hydrides. State Mendeleev periodic law. He said that elements, he basically said that the property of elements are the increasing order of their atomic masses. Like that only you will have to just write. Why could no fixed position to be given to hydrogen in the Mendeleev periodic table? It is because it shows resemblance to alkali metals and as well as with the halogen, that is the fluorine one. Okay, then how and why does the atomic size vary as you go from left to right in the period? This one I have told you many times. In the period, same shell is there, okay, but the effective nuclear charge keeps on getting increased. Effective nuclear charge keeps getting increased. Down the group, it is always from left to right. Yes, first I'll finish this. There is same number of shell, but the effective nuclear charge keeps on getting increased. Okay, meaning to say that when we go from left to right, atomic size decreases. It decreases. Okay, but when we go down in the group, the number of shells keeps on getting increased. 1, 2, then in the next one 3, then 4, then 5, and so on. So in a group from top to bottom, the atomic size increases, right? Now let us go to the next question. Question number 10. Elements P, Q, R and S have atomic number 11, 15, 17 and 18 respectively. Okay, it is shown there. Identify which of them are reactive nonmetals. Also give reason to your answer. So first of all, try to write its electronic configuration. It will be 2, 8, 1. It will be 2, 8, 5. It will be 2, 8, 7. It will be 2, 8, 8. So they are asking non-metals. So non-metals always gain electrons, right? So now try to identify them. Now see, if you see P, its electronic configuration is 2, 8, 1. That is, it will lose 1 electron to attain the octet. That is, then it will be only 2, 8, right? Now if you see Q, it is having 5 in its outermost shell. It is in need of 3 more to complete its octet. Okay, so it will be taking, okay, it will be taking 3 electrons from any another atom. Now R 2, 8, 7, so 7 are there in the outermost shell. It is in need of just 1 more electron, right, to complete its octet. So they will gain, Q and R will gain electron. And if you see S, it is having its last shell octet filled. In the last shell, 8 electrons are already there. Its valency is 0 simply. So Q and R are the non-metals here. So answer will be Q and R, and this is its explanation part. 11th question. What are group and period in the periodic table? The vertical columns are called as the group and the horizontal rows are called as period. 2 elements M and N belong to group 1 and 2 respectively. Okay, so this is group 1 and it is in group 2, N1, right? So if it is in group 1, its valency will be, it's group 1, so its valency will be 1, remember. Okay, the group tells us the the valence electron basically. So it will be losing one. Then N will be in group 2, so it will have 2 as its valence. I will write here valence electron, not valency. So it will have 2 valence electrons here. So obviously they both will lose to complete its octet. So it will lose its 1 electron, it will lose its 2 electron. So its valency will be 1, its valency will become 2, right? Respectively, and are in the same period of the periodic table. That is, this is group 1, this is group 2, and they belong to the same period. Period is same, that is, here it is M and here it is N, likewise in this way. Okay. Now, so first part is, what about the size of their atoms? So M is coming first as compared to N. Okay, so obviously M will have greater atomic radii, or its atomic size is more. Atomic size is more, because you know that when we go from left to right in the period, the atomic size always decreases. So M will be having greater atomic size as compared to the N. Their metallic character, M will be more metallic. M is more metallic. Why? Because its valency is 1. So it will quickly lose it. Their valencies in forming oxides. So if M will combine with O and if N will combine with O, right? So M valency is 1 and N valency is 2. Oxygen valency, you know that it is 2. So this 2 will go to M and this 1 will go to O. So it will be M2O. Here this 2 will go to N, this 2 will go to O. So here it will be NO only. Why? Because when valencies are same, they are never shown, or either if they are 1, right? So it will be NO. Molecular formula of their chlorides, that is M and Cl chlorides. M and Cl, that is compound with chlorine. This is M and this is N. Now again we will be using valency. The M valency is 1 and Cl valency is also 1. N valency is 2 and Cl valency is 1. Now in this case, this M will have 1, this Cl will have 1. So its formula will be MCl, right? Here this 1 will go to N, this 2 will go to Cl. So here it will be NCl2. Okay. Now let us go to the next question. Yes, what is meant by periodicity in properties of element with reference to the periodic table? Like when we are seeing the same kind of the properties getting repeated, okay, or when you are seeing a pattern, that is called as the periodicity basically. Then why do all elements of the same group have similar properties? If they are in the same group, okay, so it means that they have same number of valence electrons. Okay, so if they have same valence electron, valency will be same. Valency will be same, right? For example, if you see the example of group 17, let us say you are having fluorine and chlorine. Okay, you know that its atomic number is 9 and it's 17. So it is having 2,7 its electronic configuration. If you see Cl, its electronic configuration will be 2,8,7, right? So they are having the same valence electron. Okay, and that is why their valency is also same, that is 1. Okay. Now, how will the tendency to gain electrons changes as we go from left to right across a period? Okay, when you are going from left to right in a period, okay, that is from here if you start. So in the period, this is the left one and this is the right one which I have drawn here. Now they are asking how will the tendency to gain electron change as we go from left to right across a period and why. Now coming back to the B part, I have told you here that they have got the same number of electron. That is why they have got same valency, right? And this is the example for that. And you can also add one more line here, that since the valency is same, so they form the similar kind of compounds, or they show similar kind of chemical reactions. Chemical reaction or the similar kind of compounds they form. Okay, now coming to the question number C. So this is a period left to right. So when we go from left to right, remember the number of the shell will remain same if they are in the same period. Okay, so suppose if it is period 2, so in the beginning you will have 2 shell, in the end also you will have 2 shells to it, right? Now if you will try to add one more, like for example here, if you see this is the lithium, okay, then beryllium, then you are having boron, so on, and in the last you will have fluorine right here. Okay, so it will be having 2, 1, it will be having 2, 2, then 2, 3, and here it will be 2, 7. So they are asking you that how will the tendency to gain electron changes as you go from left to right across a period. Okay, now see, lithium will try to lose, it will not gain. Okay, why? Because it is having only one more in its second shell. So to complete octet, it needs 7 more. So it is better for it to lose this one electron and be happy with the one first shell which is having 2 in it. That is maximum in the first shell, there can be 2. Right. So here in the beginning, they all will lose lithium, beryllium, boron. In the center you will have the carbon here. Carbon will be having valency 4, that is 50-50 state is there. That is why carbon never lose or gain, right? Then if you go towards the end of the period, you will have fluorine here. Okay, fluorine is 2, 7. Okay, and you are having oxygen, and then you are here, it is the nitrogen also, like 2, here 2, 5, then 2, 6, like this. So what happens here, nitrogen is having 5 in its valence electron here, oxygen is having 6, and fluorine is having 7. So if fluorine is having 7 in its outermost shell, it needs only one more to complete its octet. So it will be quickly accepting 1, right? If you will see, oxygen, it is having 6 electron in its outermost shell, so it is in need of only 2, so it will be accepting 2, it will not lose. Remember, it is having 5, so it is in need of 3 more, so it will be also accepting. So tendency to accept will increase in the period when we go from left to right. Okay, and as you can also write that the non-metallic character getting increased, that line also you can add. So if it is a non-metallic character is getting increased, it means that tendency to gain electron will also increase. Then what physical and chemical properties of elements were used by Mendeleev in creating his periodic table? Now see, physical property was the atomic mass basically here. So physical property, if you see, it is basically the atomic mass. I don't know what is happening with this pen again. So here it is the atomic mass, and the chemical property is the hydride, how they react, or the compounds formed by them with the hydrides and with the oxide formulas and all, those are the chemical properties. So physical will be the atomic mass, and chemical will be the formula of the oxides and the hydrides. List 2 observations which posed a challenge to the Mendeleev periodic law. So the you can write any 2 disadvantage of the Mendeleev periodic law here. Like first one, you can mention that position of the isotopes cannot be justified because they are having the different atomic masses, and we just cannot put it in the same slot because then they will have to have the same atomic mass, but they differ in the atomic masses, and the whole table was based upon the increasing order of the atomic masses, right? And then you can discuss that the order of the increasing atomic masses cannot be maintained. You can also write about the position of the hydrogen, okay, because it was showing resemblance to both alkali as well as to the halogens also. So here the physical will be the increasing order of atomic mass, and chemical will be the formulas of the oxides and the hydrides. Now let us go to the next question. The pen was not working there, so I have not written, although we have discussed its answer, remember. Now question number 14. Why do we classify elements? Okay, why we are classifying elements? Elements can be whenever we are trying to classify elements, it is why, because it makes our study easier. It makes our study easier. Okay, that is why we are classifying the elements here, because then it makes easy to study their chemical and their physical properties. Because of that, let me check the pen first. Why now it is working, I think. Yes. So I'll go back to the previous question first, the question number 13. The physical property, property which Mendeleev used is the increasing order of atomic mass, here. And the chemical, you can write the formula of the oxides and the hydrides. Right, and here you can discuss the position of the isotopes. That point you can discuss. You can also discuss the position of hydrogen. Okay, hydrogen position you can also discuss here. Then you can also discuss the problems because there are certain elements which cannot be placed according to the increasing order of atomic masses. Right. Now let us go to the question number 14. Why do we classify elements? We classify elements because it makes our study easier. Study of the properties of elements. Properties of the elements. Okay, it gets easier because there are a lot of physical and the chemical properties which can be easily understood and remembered if they are correctly classified. What were the two criteria used by Mendeleev? This one I have told you many times. That is, first is increasing order of atomic mass. Second, formulas of their oxides and hydrides. Why did Mendeleev left some gaps in the periodic table? He left some gaps in the table for the undiscovered elements, and he has even given the name to them. Okay, like aluminium and so on. Okay, there are examples in the NCERT book. You will have to remember them. Okay, in Mendeleev table, why was there is no mention of the noble gases like helium, neon and argon? Because during that time these gases were not discovered. People were unaware of them. That is why there is no mention, or there is no place for the noble gases. Would you place the two isotopes Cl35 and 37 in different slots because of their different atomic masses, or in the same slot because their chemical properties are same? We will be putting it in the same slot. Okay, because they are having the same atomic number, or you can say that they are showing the similar chemical properties because of their similar chemical properties. Okay, but in the Mendeleev table there is no chance, because the table was made in the increasing order of atomic masses, and that is why it is one of the drawbacks of the Mendeleev's table. But yes, we will be putting into the same slot because they are showing the similar chemical property. Right. Now let us go to the next question. The table shows the electronic structure of the four elements here. Right. P is 2 comma 6, Q is 2 comma 8 comma 1, R is 2 comma 8 comma 7, S is 2 comma 8 comma 8. Identify which elements will form covalent bond with carbon. Okay, so we will have to see elements which can form covalent bond with carbon here. So now if you see the P here, P is having electronic structure 2 comma 6. That is, it is having 6 valence electron in its outermost shell. So its valency is 2 here. Okay, here it is 2 comma 8 comma 1. So its valency is 1. Here its valency is 1. And here S 2 comma 8 comma 8 valency is 0. So it will form like this one is it is having valency 0, that is it is a noble gas, so it will not form any compound. So it will not form any kind of compound, right? So this is out of question now. So only P, Q, R you can see here. Okay, so now this one, it can easily form a covalent bond with the carbon. Okay, because its valency is 1, so it can easily form, you can say, like for example 2 comma 8 comma 7. So it is telling us that it is a kind of halogen, right? So it can easily form like CCl4. Okay, so it can form like Cr4 here similarly. So R can definitely form. Now coming to this one, this is a typical metal example. Okay, this is a typical metal example. So it can or it cannot, but I think that it will not form compound. Although P can form compound, it is having the it is having 2 its valency, so it can form a compound, a covalent compound with carbon. Yes, compound with carbon. Okay, like CO2 you can say simply here, like not if like for example it can share its elements with it also, valency can be shared. Okay, it is just a hint, it is not an example. Here also it is just a hint, remember. Okay, so now let us go to next question. Yes, the diagram below shows part of the periodic table. Which elements would rather react together to form covalent compounds? Okay, so would react together to form covalent compounds, they are saying, between two elements W and Z, which will have a higher atomic radius, and why? So for that you will have to see the position here. So it is group 17 here. Just a minute. Yes, it is group 17 here, it is group 16, it is group 2 here, right? So which element would react together to form the covalent compound? Now here its valency is 2 here simply, right? And its valency will be 1. So they can also combine together to form the you can say covalent compound. Okay, and here out of W and Z, which will have more atomic size. So Z is having only you can say 2 shells because it is in the second period here, and this is in the 4th period, so it will have 4 shells. So obviously the size of W will be more, right? Now next question. Choose an element from period 3 of the modern periodic table that matches the description given below. Give reason for your choice. Okay, so it is period 3 they are saying. So period 3 starts with Na. Okay, 3 shells, atomic number is 11, 1, 2, 3. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and then argon, atomic number 18, right? and the number of shells will remain same. So this is a period 3. Now you will have to choose. It has a similar structure to diamond. Diamond is made from carbon. You know that its valency is 4, and it will be quite similar to silicon. Okay, so the answer here will be silicon. It has valency, it has same valency as lithium, so it is sodium. Okay, lithium atomic number 3, so 2, 1, and here it is 2, 8, 1, right? It has variable valency and it is a member of the oxygen family. Hint is there, it is group 16, so it is obviously sulfur here. Next question, number 18. Chlorine has atomic number 17. By what process will it be able to attain a noble gas configuration? So chlorine is having atomic number 17, so its electronic configuration will be 2, 8, 7. So they are asking you that by what process it will attain a noble gas configuration. Now see, the first easiest method is to gain 1 electron, right? Then it will be changing to 2, 8, 8. Okay, so it can, like Cl forms the Cl anion quickly, so it can go under the ionic bonding, and it can also show covalent bonding. Okay, now for example, in the covalent bonding, if you see, if it is carbon here, carbon is having 4 valencies, okay, around it, and Cl with its 1 valency, I'll put a cross for that, right? So this is like you will have to put the 7 electrons, 1, 2, 3, 4, 5, 6 and 7 here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and this is the 7th one. So this Cl can share 1 electron with the carbon, and carbon 1, 2, 3, 4, and 1 it will take from the neighboring Cl, like this, right? Now if you will be seeing this Cl, it will also complete its octet by sharing 1 electron with the carbon. Okay, so in this manner it can show the covalent bonding also, and among the Cl2 also, like Cl and Cl, let us say. Okay, so this is having 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, right? So it will share with its neighboring 1 electron here, and it will also share with the neighboring to complete its octet. So it can be done like easily through the covalent bonding also. It can complete its octet, and also through the ionic bonding also. Now this ionic bonding, this example you know from the class 9th itself, like NaCl is the most common compound. If you see Na, its electronic configuration is 2, 8, 1. So this is, suppose this is the Na, so this is the first shell, this is the second shell, this is the third shell, right? In the first there are 2 electrons, in the second you will have to draw 8, 1, 2, 3, 4, 5, 6, 7, 8, and in the last there is 1. Now near to it, if you will draw Cl, 1, 2, 3, this is the Cl, 2 electron in the first, 8 in the second, 3, 4, 5, 6, 7, 8, and in the last one also 7, 1, 2, 3, 4, 5, 6, 7, right? So it is in need of 1, but Cl is easily giving 1 electron, so this 1 electron can be accepted by Cl. So Na will become positive, Cl will become negative, so they will form the compound NaCl because they are having the opposite charges to them. So chlorine can complete its octet by ionic bonding as well as by covalent bonding. name the neutral atom in the periodic table which has the same number of electron as Na plus and Fa minus. Support your answer with suitable explanation. Now Na, if you see, its electronic configuration is 2, 8, 1 because its atomic number is 11. Fluorine, it is 2, 7 because its electronic configuration is, its atomic number is 9. So I'll write 9 here, 11 here, atomic number, and that is why it is their electronic configuration. Now sodium always lose to attain the electronic configuration, so it loses 1, so it becomes 2, 8, and that is why it is having the positive charge to it. Now Cl, it always gain 1 electron and it becomes 2, 8, and that is why it is having negative charge because it is gaining, right? Now if you see the order, you can say the order in which these elements are arranged, the neon is having the atomic number 10, that is 2, 8. Neon is followed by sodium. Okay, atomic number is 11 and it is 2, 8, 1. And before to it lies the fluorine, atomic number is 9, 2, 7, right? But after gaining, it is becoming 2, 8, right? And sodium, after loss of 1 electron, okay, it is also changing to 2, 8. So they both are attaining the electronic configuration of the nearest noble gas, that is the neon. So answer will be neon. The neutral atom in the periodic table which has the same number of electron, here it will be neon, because after the loss or the gain, they are attaining the noble gas configuration of neon. Then next question, an atom of an element has the electronic configuration 2, 8, 5. To which period and group does it belong? It is 2, 8, 5, right? So it is having 3 shells. So it is period 3. Okay. Now valence electron are 5, right? So if valence electron are 5, so it is group number 15. Okay. Question number 21. An atom has electronic configuration 2, 8, 5. Calculate the number of proton. Electronic configuration is always telling us the number of electrons. Number of electrons are always equals to number of protons. So if number of electrons are 2 plus 8, 10, 10 plus 5, 15. So the number of proton will also be 15. So here it will be 15. Is it a metal or a non-metal? You can see its electronic configuration. It is 2, 8, 5. So it will try to gain 3 more electrons. Okay, so if it is gaining, it is a non-metal because metals always lose, right? So it is a non-metal. Okay, then observe the given table and identify the elements that belong to the same group. Okay, you will also have to give answers for your reason. So elements are P, Q, and this is R, sorry, not Q, this is R, P, Q, R, right? So it is 5, 9 and 17. So its electronic configuration will be 2, 3. This one 2, 7. This come 2, 8, 7. Now they are having the same valence electrons. See, 7 and 7. So Q and R will be in same period, sorry, in the same group, as they have same valence electron. In the group, the valence electron remains the same. Okay, so if they are having 7, 7 in their outermost shell as their valence electrons, so they will be in the same group. Okay, the next part, PQR belongs to group 1, 4 and 17 respectively of the periodic table. Which two elements will form ionic compounds? Ionic compounds means positive and negative ion should be there. Positive are formed by the loss of electron. Negative are formed by the gain of electron, right? So you will have to look for them. So if it is group 1, so it will obviously lose electron, and the group 17 will gain electron, right? So in this way P and R will form the ionic compound. Okay, predict the formula of the compound. So for that you will be using valency. P belongs to the group 1, so valency will be 1, and R belongs to group 17 here, right? So group 17, that is 2 comma 8 comma, you can say the last valence electron will be 7, so valency will again be 1. So this one will go here, this one will go here, so the formula will be PR only. Okay, now let us go to the next next question. Question number 22. Question number 22. There are 3 elements X, Y and Z with their atomic numbers 16, 18 and 19. Okay, examine the given data and answer the following question. How many valence electrons are there in Y? So Y, it is having electronic configuration 2, 8, 8. So 8 is the valence electron. They are asking valence electron, not valency. So it will be 8 electron. What is its valency? Its octet is complete, so valency will be 0. It is not in need of any more electrons, so valency will be 0. Write the position of X and Z in the modern periodic table. So X is having atomic number 16, that is 2, 8, 6, right? And Z is having 19, its atomic number, so it will be 2, 8, then 8 and 1. Okay, so it is 19 total. So it is having 6 electron in its outermost shell, that is the valence electron are 6 here. Okay, so if 6 is the valence electron here, valence electron are 6, so it will be in group 16. Okay, and period will be 3. Why? Because it has got 3 shells, first shell, second shell and third shell. Now if you see Z, its valence electron are 1, so it will be in group 1, and period will be 4 because it has got 4 shell, 1, 2, 3, 4. Okay, now let us go to the next question here. Question number 23. Okay, X, Y and Z are the elements of the Daubeney triad. If the atomic mass of X is 7 and that of Z is 39, what should be the atomic mass of Y? So for the Y, for the middle element, we always do the sum of the first and the last and we divide it by 2, or you can say that average we take. So X plus Z by 2 we will have to do. X is 7 plus 39 by 2, so it will be 46 by 2, that is 23. Okay, so Y atomic mass will be 23 here. Element X forms chloride with the formula HCl2, which is a solid with high melting point. So if see, high melting point means that it is an ionic compound. Ionic compounds show high melting point, not the covalent compound. So you are getting a hint. X most likely to be in the same group of the periodic table as which of the following elements. Okay, so you will have to guess that X resembles to which of these, Si, Mg, Al and Na. Okay, and you will have to give answer. So first of all, XCl2, so that is X valency is 2 here. Okay, because valency always goes to the neighbor, so XCl2. So X valency is written at the foot of the Cl, that is it is 2, and Cl valency will be written at the foot of X. Okay, and we know that Cl valency is 1 and 1 is never shown. So X valency is 2. First of all, you are getting the valency clearly. Second hint you have got that it is like it can be a metal or it can be a non-metal. Okay, why? Because it is forming a ionic compound, and ionic compound is like they are always having the high melting point. So if you see silicon is a metalloid, so it is out of question that X will resemble to it. So silicon cannot be the answer. If you see Mg is 2,8,2, its atomic number is 12, right? So its valency is 2. So Mg, X can be resembling to Mg. Okay, now we'll check other options also. Aluminium, its valency is 13, 2,8,3. So it cannot be Al, like it cannot resemble to Al because its valency is 3 and X valency is 2. If you see sodium, atomic number 11, 2,8,1. So again it is having valency 1. So X will resemble only Mg because the valency is here 2. Mg valency is 2 and X valency is also 2, and Mg is also a metal. Okay, now we'll go to the next question. This is question number 23. Where's question number 24? Let me check here in this one. No. Maybe the order is wrong here. Position of 12 elements in the modern periodic table is given below. Okay, where atomic numbers are given in bracket or in parenthesis. Predict the nature of Si and Ge. Si and Ge, so it is 2, 8, 4. It is a metalloid simply. Okay, and Ge is also a metalloid. So they are not having clear properties of a metal or a non-metal. Okay, so that is why they are kept at the borderline of metals and the non-metals, and they are called as metalloid. Identify the element with smallest atomic radii. Okay, which will be having smallest atomic radii. Now see, it is the period 2, so it will have 2 shell. Period 3 will have 3 shell. Period 4 will have 4 shell. Period 5 will have 5 shells, right? So they are asking you smallest, not the biggest. So obviously it is 2 here. Period 2 is having only 2 shells, so it will be smallest. But in period 2 we are having B and C here. Now B and C, they belong to the period 2, and in the same period when we go from left to right, the atomic radii decreases. Atomic radii decreases, right, because of the increase in total nuclear charge or the effective nuclear charge. So C will be having the smallest radii. So answer will be C here. Now let us go to the next question here. Question, yes, it is having a part of the periodic table again here, and we will have to give answer. The neutral atom of an element E, okay, consists of 12 electrons in its atom. In which group and period is E placed? Okay, so in which group and period E is placed? So it is having the E is having atomic number 12. Its electronic configuration is 2, 8, 2. So valence electrons are 2 here, right? Valence electrons are 2. So it will be in group 2 or, okay, it can be in the group 2 simply, yes. So in which period and group? So period will be 3 because the number of shells are 3. Number of shell is 3. Okay, so period will be 3, right? So you will have to check, this is the period 3, this is the period 3, okay, and the valence electron are 2 here in this case, 2 comma 8 comma 2. Name the, so you can write here period will be 3 because the shells are 3, and it will be group 2 because the valence electrons are 2. Name the element E. Element E will be Mg. How many electron needs to lose or gain to achieve noble gas configuration? So E is having 2 electron in its outermost shell. It needs to complete octet. So for octet it needs 6 more. So it will not be able to gain, so it will lose. It will lose these 2 electrons to complete its octet. Okay, because after loss of these 2 electrons, it will be having only 2 comma 8, that is both the shells are completely filled here. So it will lose 2 electrons. Write the formula of chloride of E. So E will combine with Cl, so its valency is 2 and Cl valency is 1, so this 1 will go to E, this 2 will go to Cl, so it will form ECl2. Right. Let us see the next question. The next question is 27 question. Among all periods, which one is incomplete, and what are the important properties exhibited by all elements present in this period? So according to the modern periodic table, if you see, this is the period 7. This is the period 7, okay, which is incomplete. You can mention the names of 1 or 2 elements from this period. Then question number 2, list the drawbacks of Daubernier's triad. Okay, so there was one main disadvantage of the Daubernier's triad, that he was able to identify only 3 triads, right, from the known elements. Like whatever number of elements were known at that time, from that number of elements, he was able to identify only 3 triads. Okay, now let us go to the next question, that is question number 28. The given figure demonstrates the periodic table. Based on the figure, answer the following question. Write a chemical reaction between R and S. So you will have to find a chemical reaction between R and S. So for that you will have to find the valency. Now R is in the group 2, okay, right? R is in the group 2, so the valence electrons will be 2 and the valency is also 2 here. S is in group 17, so valence electron is 7 here and valency is 1. Okay, so R and S, R is having valency here 2, S is having valency here 1. Okay, so this 1 will go to R, this 2 will go to S, and it will form RS2. What type of ions will be formed by R and S? R will lose its 2 valence electron to attain the noble gas configuration, and S will gain 1 electron to complete its octet. So here it will lose 2 electrons to complete its octet, here it will gain to complete its octet, right? So in this way R is losing, so it will become positive in charge, and S is gaining, so it will become negative in charge. So it will form cation, R will form cation and S will form anion, right? Now let us go to the next question. Again it is showing a part of the periodic table. The elements are arranged according to their according to their atomic number, and the letters are not the chemical symbols. Which element has a bigger atom, A or F? So now first of all look at the position of A. A is having atomic number 3 here, you can see. So it will be 2, 1. Okay, so it is having 2 shells, and F is here, its atomic number is 8. Right, now its electronic configuration will be 2, 6. So they both belong to the same period because they are having the same shell, remember, isn't it? So when we go in the same period from left to right, the atomic radii always decreases. So which has a bigger atom? So A will have a bigger atom. It will be bigger or biggest in size. So it is big in size as compared to the B, C, D, E, F, G, H. Which element has a higher valency, I or O? Okay, so here instead of O you can write K here. It is a misprint here. Okay, I or K, which is having a higher valency, you can say. So I position is here, its atomic number is 11, so it is 2, 8, 1, its valency is 1. If you see K here, K is 13, it is 2, 8, 3, so its valency is 3. So obviously K will be having a higher valency, that is 3 here. Which element is more metallic, I or K? So when we go from left to right in a period, that is, they all belong to the same period, I, J, K, L, M, N, O, P. Okay, so the metallic character keeps on getting decrease. So I will be more metallic as compared to K. K is also metallic in nature, but I will be more metallic as compared to K. Select the letter which is showing a non-metal or valency 2. So they are asking a non-metal with valency 2. Okay, so you can see here it can be F or N. F or N can be the answer because F is 2, 6, so it is in need of 2 more to attain the octet. Clear? And it is a non-metal, that is why, because it will gain. Okay, and N is 16 atomic number, 2, 8, 6. So again it is in need of 2 more electron to complete its octet. And since it is in need of 2 more, so it will gain. So again it is a non-metal. So out of F and N, you can write any one or you can write both of them because they are having valency 2 and they are non-metal. Now let us see the next question, question number 30. Why metals are called electropositive? You can give any example. Metals are called as electropositive first of all because they lose electrons. So once they lose electron, they become positively charged. Like Na is having atomic number 11. So its electronic configuration is 2, 8, 1. Okay, so it will lose 1 electron to complete its octet. So if it is losing to complete its octet, so meaning to say that it will have only 2, 8 electron, but protons are still the same, 2, 8, 1. So the proton charge will be there. So it will become positively charged. Name 2 elements you would expect to show chemical reaction similar to sodium. Okay, so chemical reactions similar to sodium will be potassium and cesium. Why? Because they are coming in the same group. Okay, their group is 1. Okay, and that is why they are having the same valence electron. Their valency is same. And since their valency is same, so they will show similar type of the chemical reactions to us. Okay, so that is all for the today's session. If you are liking my session, then please subscribe and share it among your friends and family. And come back with a new Q&A with some other chapter. Thank you and have a good day. Bye-bye.